So look at this narrow passage between the north of Morocco and the southern part of the Spanish region. It's called the Strait of Gibraltar. There are only 8 miles between the two continents, but for some reason, there's no bridge, despite people having been dreaming for centuries about connecting these two regions. There are places in the world where a bridge over water stretches for a much greater distance. For example, the Lake Pontchartrain Causeway near New Orleans, Louisiana, goes for 24 miles, which is 3 times the length of the hypothetical bridge between Africa and Europe. That's listed in the Guinness Book of World Records as the longest continuous bridge passing over water. It consists of 2 parallel bridges and connects the urban area of New Orleans with small settlements in the north of Lake Pontchartrain. 9,000 concrete piles hold more than 1,000 decks above the water. This large-scale structure was built in the middle of the 20th century. It only took 14 months from the start of construction to its completion. American engineers created a unique technology for attaching concrete piles to the base of the bridge, and this bridge is still functioning. So, what's the problem with building a shorter bridge to connect Africa and Europe? Let's first find out the value of the 8-mile bridge that could connect 2 continents and the reason why everyone is talking about it. In fact, the value of such a bridge would be enormous. Diamonds, oil, minerals. Africa is full of valuable materials, and Europe is happy to buy these things. This theoretical bridge could allow people to transport things for trade quickly and comfortably. But now, the exchange of goods between Africa and Europe is only possible thanks to airplanes and cargo ships, and airplanes are extremely expensive because of hefty fuel price tags. In addition, air travel is often delayed because of bad weather. There are long customs procedures and transportation from the airport to the destination. Ships can also be a problem. The narrow area of the Mediterranean Sea, where the 2 continents are closest to each other, is a dangerous place because of storms and strong currents. The transportation of your diamonds is highly dependent on weather conditions. The second advantage of such a bridge would be the creation of tens of thousands of jobs. People from Europe and Africa would build hotels, ports, parks, and even small towns for each other. The coastal parts of both continents would become a new economic center. And just imagine how much investment those places would attract. Europe and Africa would be much closer than ever before. You could drive from a small Spanish town to a safari park in northern Morocco, buy Moroccan tea, get some argan oil, and go home for the evening. Or you could take a high-speed train across the beautiful Mediterranean Sea. People would open hundreds of restaurants, amusement parks, shopping malls, and a museum next to this bridge. But, unfortunately, it's impossible to build such a bridge, at least at the moment. And here's why. The main problem is the Strait of Gibraltar itself, because of its strong currents and seismic activity. How can you start large-scale construction if, in a couple of days, an underwater earthquake can trigger giant waves and take all the ships underwater? Even if you build a bridge, rapid streams of water that constantly change direction can shake the entire structure and tear the connecting parts of the construction. The bridge over the Strait of Gibraltar must have a strong, sturdy system that will withstand seismic activity. Huge resources are required to create such a complex structure. Despite the dangerous passage between the 2 continents, it remains one of the busiest points in the world. It's the only place on the planet connecting the Mediterranean Sea and the Atlantic Ocean. About 300 ships pass through this area every day. Not only merchant ships, but also fishing vessels and tourist boats. There are not so many places in the world where you can watch whales coming out of the water. Not only people, but also marine creatures often visit this passage because of the peculiarities of the sea currents. But we'll talk about that later. Another problem is the depth of the strait. In simple words, any bridge over the water is built on long metal piles. Builders and engineers stick piles into the seabed and use them as a holding base for the whole construction. But installing such piles firmly enough is a difficult task because of the uneven seabed. The seabed has a unique geological landscape, irregularities, and different densities of the Earth's rock. There are also reefs, rocks, and pits. Any seabed requires extensive geological studies before piles are installed. However, the bottom of the Strait of Gibraltar is especially difficult because of its depth, almost 3,000 feet. It's one of the deepest straits in the whole world. Just imagine, you'll need the height of 10 Statues of Liberty to reach the surface of the water from the bottom of the strait. What kind of pile should be used there to hold the entire bridge? Most likely, one pile will have to consist of several parts connected into one large metal rod. And don't forget about seismic activity. Let's say you've installed perfectly strong piles, but the next day an earthquake occurs and destroys the entire structure. And a strong current is carrying fortifications all over the Mediterranean Sea. The next problem is probably the most important one, because it concerns marine life. The Strait of Gibraltar has a high salt content. This natural element makes water heavier and makes it descend to the bottom of the deep Mediterranean basin. Then, this salt water pushes up cold water from the seabed into the Atlantic Ocean. These changes in water density, as well as fast currents, create sea vortices and turbulence. It's like a raging cauldron of cold water that raises a lot of nutrients to the surface. The hollows and hills of the Strait of Gibraltar are filled with different substances and sunlight, and this creates ideal conditions for the formation of phytoplankton. Whales, dolphins, and other marine creatures adore this delicacy. That's why you can see about 7 species of whales and dolphins in this place. What might happen to phytoplankton after the start of global construction? Carbon dioxide, crushed rock, tons of dust and ashes, falling building materials. All of this could significantly pollute the environment. Without phytoplankton, many fish would go extinct. Without fish, thousands of fishers wouldn't be able to get food and earn money. But even if the bridge was built, cars and trains would continue to pollute the air and water. This disruption of the delicate balance in this narrow strait can lead to larger-scale environmental disasters. Dolphins and whales may leave to look for food elsewhere, and thus take resources from other marine inhabitants. Like falling dominoes, one problem can follow another. And all this because of one bridge. In 2007, the Spanish Ministry of Environmental Protection introduced speed limits for all ships sailing through the strait in order to not disrupt the delicate balance of nature. At the beginning of the 20th century, a French engineer proposed a project of a bridge, but it was rejected because it was too complicated and costly. People also tried to develop a 23-mile-long tunnel, but this project also faced financial and technical difficulties. People are still dreaming of a bridge over the Strait of Gibraltar. Perhaps, in the future, when we develop cooler technologies, we'll be able to build this thing. Oh, by the way, there hasn't always been water between these two regions. In the distant past, the two continents were connected. The entire Mediterranean Sea is the remains of the Tethys Sea that existed before the era of dinosaurs. Then the African and Indian plates collided with the Eurasian one, and the Tethys Sea completely disappeared. In its place, a land bridge was formed that separated the Mediterranean Sea from the ocean. Without access to water, the sea dried up about 6 million years ago. But then, when the bridge came down, the water began to fill the dried-up pool. For tens of thousands of years, the narrow plate sank lower and lower, and the Mediterranean Sea eventually got its current water levels. If you pull up a map, here, let me do that for you. The Strait of Gibraltar looks almost laughably narrow. At its tightest point, Europe and Africa sit just about 9 miles apart. You could technically kayak that on a calm day, if only it wasn't highly dangerous. Now, engineers want to punch through rock, pressure, and moving continents to turn that ancient divide into a boring 30-minute commute. And it's going to take a lot of boring. Yeah, that's a joke. But wait, why go through all that trouble and not just connect Europe and Africa with a bridge? Well, the biggest problem is the Strait of Gibraltar itself. The water here moves fast. The currents rank among the strongest on the planet. Plus, the strait is exactly where the African and Eurasian tectonic plates meet. The African plate keeps creeping northward, slowly squeezing toward Europe. It moves ridiculously slowly, just a few inches a year. So no one is going to wake up tomorrow and stroll across. Scientists built a detailed 3D model of the region, and it shows that in about 20 years, the strait could finally close and turn into the Isthmus of Gibraltar, basically a land bridge between the continents. But why wait millions of years? Plus, right now, that slow plate movement still causes real-world trouble. When those massive slabs of rock grind against each other, they build a pressure. That pressure releases itself as earthquakes, tiny fractures, and sudden shifts in the ground under the sea. Nothing down there stays perfectly still. Even if someone managed to build a bridge, powerful streams could shake the structure non-stop and tear joints apart, unless designers created an insanely strong system. And that kind of engineering would eat unbelievable amounts of money and resources. If that's not enough, there's the depth problem. We're talking about almost 3,000 feet. That's one of the deepest straits on Earth. Any pile there would need insane length and strength, probably built from several massive sections bolted together. And even after installing them, earthquakes could still snap everything apart while currents drag pieces across the sea. But the most serious issue involves nature. The water here has a high salt content, which makes it heavier. That heavy salt water sinks into the Mediterranean basin and pushes colder water back toward the Atlantic. These movements create swirling currents, turbulence, and underwater boiling zones full of nutrients. That chaos feeds phytoplankton, tiny organisms that sit at the bottom of the entire marine food chain. Whales and fish absolutely love it there. The strange shapes of the seabed and the sunlight hitting different layers of water create perfect living conditions. If construction started, there would be dust, crushed rock, carbon dioxide, fuel, and falling materials. All of it would cloud the water and ruin the natural food chain. That's why a tunnel sounds like a better idea. Spain first proposed to build a modern tunnel here in 1930, but it was impossible to drill through hard rock with the technology they had at that time. But then, in December 2003, Spain, this time together with Morocco, decided to go back to the idea and build a tunnel that would connect the rail systems of the two countries. It took them another 20 years to start designing and planning the tunnel. Now, construction is scheduled to start in 2030 and will take around 10 years. This tunnel will need to be a true engineering marvel that will live with the motion of tectonic plates, not go against it. The structure will need flexibility, shock resistance, and a safety margin for movements that no one can perfectly predict. So, according to the new project, the tunnel would plunge down to more than 1,000 feet below sea level at its deepest point. That makes it about 6 times deeper than the Channel Tunnel between England and France. Now length matters too. The full tunnel would stretch close to 25 miles, with roughly 17 miles directly beneath the seabed. Once you're in the middle, you're farther from open air than most people will ever be in their lives. It means no quick exits or easy rescues. Everything has to work perfectly. Ventilation, power, signaling, because there's no backup plan called just open a door. If it does work out, high-speed trains could carry passengers and freight from Spain to Morocco in about 30 minutes, something close to a regular subway ride. And that's not just convenience. That's a rewiring of trade routes, labor movement, tourism, and economic gravity between continents. More than 12 million people could travel on that route every year. Now, the design won't rely on one, but 2 parallel twin rail tunnels, one for each direction, plus service and emergency corridors in between. All of this will cost around $10 billion. And engineers will need to design something flexible enough to bend, absorb, and survive slow continental drift and constant pressure. The tunnel won't go against Earth. It will ride with it, like a shock absorber built into the planet itself. And this idea doesn't come out of nowhere, as humans have already built impressive underwater tunnels. The Channel Tunnel, the most famous example, already turned 30 in 2024. It runs under the English Channel, linking England and France. Trains can zoom through it in about 30 minutes, hitting around 99 miles an hour, and it's the longest underwater tunnel in the world as of now. 3 tunnels are running parallel under the seabed. 2 of them carry trains, 1 in each direction, and the third is a service tunnel in the middle used for maintenance access, evacuation, ventilation, and just general support. The whole thing was privately funded and crazy expensive. It went over budget, and while it eventually turned a profit, it hasn't been the financial goldmine people hoped for. Despite that, engineers still consider it one of the most impressive feats of modern civil engineering. And they even connected continents underwater before. Istanbul's Eurasia Tunnel has a 3.3-mile section that goes straight under the water. It links Europe and Asia by road in about 15 minutes. What once took nearly 2 hours now feels routine. The tunnel took 55 months to build and cost $1.3 billion. They had to reorganize traffic for it to make the access roads of the best quality. And the tunnel didn't just connect continents, but also helped reduce atmospheric and acoustic pollution in the city. Right next to it, the Marmaray Rail Tunnel slides trains beneath the same strait, carrying commuters between continents like it's no big deal. These tunnels sit in an earthquake zone under shipping lanes, beneath constant currents, and they work. Once you see those projects, the Gibraltar Tunnel stops sounding insane and starts sounding possible, maybe even inevitable. Which naturally leads us to the most dangerous thought humans ever have. If we can do that, what else can we connect? Well, that's where the dream goes full sci-fi. People imagine stepping onto a train in New York and stepping off in London less than an hour later. No jet lag, no turbulence, just a straight shot beneath the Atlantic. Some proposals throw around numbers like 54 minutes, but that speed requires vacuum trains moving around 5,000 miles per hour. That technology doesn't exist outside of lab concepts and computer models, yet. Now, even if we ditch the sci-fi speed and use conventional rail, the trip would take roughly 15 hours, slower than an 8-hour flight. Then comes the real nightmare. The Atlantic is 12,000 feet deep on average, with pressure, geology, and distances that make Gibraltar look like a backyard project. Engineers would face earthquakes, underwater mountains, volcanic zones, and even finding a leak would feel impossible. Fixing it would be next level. The energy costs alone would make today's mega projects look cheap. That's why right now, a transatlantic tunnel lives in the same category as warp drives and cities on Mars. Inspiring, useful for pushing ideas forward, but not something you break ground on next year. The Gibraltar Tunnel, though, sits right on the edge of that line between impossible and inevitable. What once separated civilizations now tempts us as a corridor. What once seemed impossible now connects continents.
Some mistakes have the power to change the course of history. One such story has to do with an old, boring key that could have saved the Titanic from its infamous demise. The key belonged to the crow's nest locker that housed binoculars, which could have helped the lookouts spot the iceberg sooner. There's more. The key wasn't even on board the ship when it set sail. The second officer took it with him when he was taken off the ship at the last minute. As the story goes, the officer forgot to hand the key over to his replacement in his hurry to disembark. So, when the lookouts were in desperate need of binoculars, they were out of luck. One of the lookouts, named Fred Fleet, even testified that if they had had binoculars, they would have spotted the iceberg in time to avoid it. And when asked how much sooner, Fleet replied, "Enough to get out of the way." In 2015, some auctioneers got their hands on Blair's key and presented it as one of the most important artifacts from the Titanic. They truly believed it could have saved the ship. Blair kept the key as a souvenir and passed it down to his daughter, Nancy. At one point, it was up for auction with a price tag of over $80,000. Blair himself was quite the hero, it seems. A year after the Titanic disaster, he was awarded a gallantry medal for saving a crewman who had fallen overboard while he had been on board the liner Majestic. He may have forgotten a key, but he sure didn't forget to be a hero when it counted. This next story is both funny and tragic. It's about NASA's lost $125 million Mars Climate Orbiter. The spacecraft engineers failed to convert from English to metric measurements before the craft was launched, and as a result, they lost it. The navigation team at the Jet Propulsion Laboratory used the metric system of millimeters and meters, while Lockheed Martin Astronautics in Denver used the English system of inches, feet, and pounds. JPL engineers mistook acceleration readings measured in English units of pound-seconds for a metric measure of force called Newton-seconds. What's worse is that none of JPL's quality control procedures caught the error in the 9 months it took the spacecraft to make its 461 million-mile flight to Mars. That's a long time to be lost in translation, don't you think? The miscalculations were enough to throw the spacecraft so far off track that it flew too deeply into the Martian atmosphere and was destroyed when it entered its initial orbit around Mars. It's embarrassing to lose a spacecraft to such a simple math error. And it's hard to think of another example of such a large loss due to English versus metric confusion. Ever heard about the mathematical mistake that led to the discovery of the New World? Spoiler alert, it involves a guy named Christopher Columbus and a really big globe. Back in 1492, Columbus set sail from Spain with a mission to find a new trade route to Asia. He was convinced that he was less than 3,000 miles away from Japan, and just a bit more sailing would get him to the Indies with all their tasty spices. The only problem was that Columbus was a bit off in his calculations, like way off. He made a mistake in estimating the size of the globe, which led him to believe that Earth was far smaller than it actually is. Now I know what you're thinking. Wasn't Columbus afraid that he would fall off the edge of the world? Contrary to popular myth, Columbus and his crew knew the Earth was a globe, just like the ancient Greeks did 2 millennia earlier. They weren't worried about falling off the edge, but rather about the size of the ocean they planned on crossing. And to make matters worse, Columbus had no idea that an unknown landmass existed between Spain and Asia. After weeks at sea, Columbus finally reached the Caribbean. He believed that he had landed on the outskirts of Asia, and so named the islands the West Indies. He went on to explore the Caribbean and the northern coast of South America. But here's where things get really interesting. Even though Columbus insisted until his last day that he had reached Asia, another Italian explorer named Amerigo Vespucci mapped the eastern shore of South America down to Brazil and proved conclusively that Columbus had actually discovered a whole new world. A German mapmaker saw Amerigo's maps and labeled the new landmass America after him. And since his maps were super popular at the time, the name stuck. One man named Alexander Fleming stumbled upon one of the most significant medical discoveries of all time by accident. At one point in his career, Fleming observed the demise of many people from uncontrollable infections. Antiseptics were used to fight this, but they often did more harm than good. In 1922, while he had a cold himself, Fleming transferred some of his, nasal discharge to a petri dish and left it on his cluttered desk. When he finally examined it weeks later, he found that an enzyme had some antimicrobial properties. It wasn't until 1928, when Fleming left an uncovered petri dish next to an open window, that he stumbled upon the discovery that would change the world. The dish became contaminated with fungus spores. And when he examined them under the microscope, Fleming discovered that the bacteria near the fungus were dying. He managed to isolate the fungus and found that it was effective against numerous things that caused diseases. And thus, penicillin was discovered. As Fleming himself put it, "I did not discover penicillin. Nature did that. I only discovered it by accident." Talk about a lucky break. In the early 1520s, the east coast of the United States of America was a big mystery waiting to be solved. The Spanish found Florida, and the English and Portuguese found Newfoundland, but the area in between was like a blank spot on the map. France decided to take action and sent an expedition to explore the area. They chose a guy called Giovanni da Verrazzano to lead the trip. For this expedition, he got 4 ships. Unfortunately, 2 of them were shipwrecked, and a third one went home after doing some other business on the Spanish coast. Only the flagship, La Dauphine, crossed the Atlantic with Verrazzano and his 50-man crew. Verrazzano set sail from Madeira and landed at Cape Fear. From there, he sailed south, but got a little scared of running into the Spanish, so he returned somewhere north of Charleston. He anchored not far from his original landing spot, but unlike other explorers, he preferred to anchor well out at sea. He did send a boat to the shore, and he met the natives. They were described as wearing just some animal skins covering their bodies and garlands of bird feathers. As Verrazzano sailed along the coast, he reached the outer banks of North Carolina. He thought that the waters he discovered were those of the Pacific. In reality, what he'd stumbled upon was the Pamlico Sound. He thought that North America was just a long, extremely narrow strip of land. This mistake led mapmakers to show North America as almost completely divided in two. Moving on, Verrazzano reached a beautiful place that he called Arcadia, probably Kitty Hawk, North Carolina. Sailing further north, he missed the entrances to Chesapeake and Delaware Bays because he kept quite far from the coast until New Jersey. Then, the moment we've all been waiting for, Verrazzano discovered New York Harbor, and he anchored in the Narrows. Later, it was named after him, and now it is spanned by the Verrazzano Narrows Bridge. Once Verrazzano's sea appeared on the map, it became widely accepted and impacted loads of future explorers. For example, Henry Hudson went looking for a passage to the Pacific in the middle latitudes of the continent. But, as it turns out, the Englishman never did find the Pacific Ocean anywhere near Virginia. And the cartographic myth eventually faded away. It's funny to think about how a mistaken belief could have such an impact on history. Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place, It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research, but this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents, which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
If you had landed on Earth a really long time ago, about 1.5 billion years in the past, you wouldn't have recognized our planet. At that time, all the land was stuck together in one giant supercontinent called Nuna, which was surrounded by an endless ocean. But if you had stuck around, you would have witnessed a planetary-scale disaster, Nuna falling apart. But the most amazing thing is that apparently, when Nuna started breaking apart, it kicked off changes that made Earth a much better place for life. Scientists used to call this part of Earth's history the boring billion. It lasted from about 1.8 billion to 800 million years ago. Not much seemed to happen during that time, hence the name. No big climate changes, no bizarre life forms, and nothing very dramatic. Turns out the name isn't very fair. Things may have looked calm on the surface, but underneath, Earth was changing a lot. Continents were moving, splitting apart, and coming back together. 2 massive supercontinents, Nuna and later Rodinia, formed and broke up during this time. When Nuna began to break apart, huge cracks opened between the drifting land pieces. Water filled those spaces, creating shallow seas. Those seas were warmer, calmer, and had more oxygen than the deep oceans that existed before. And that might have changed everything. The new seas created friendlier conditions for life to grow and change. Scientists now think they may have helped early life become more complex. They looked back 1.8 billion years and rebuilt how Earth's tectonic plates moved over time. Plus, they tracked how carbon was stored inside the planet and released into the air. The researchers did this using a new advanced computer model that gave way more detail than they had ever had before. They found out that during the 350 million years of the so-called boring billion, the amount of shallow seas along the edges of continents doubled. Altogether, these coastlines stretched about 81,000 miles. That's more than 3 times around Earth at the equator. At the same time, subduction zones, places where one tectonic plate slides under another, actually got shorter as the continents shifted around. This is important because subduction zones are where a lot of volcanoes come from. When one plate sinks under another, seawater gets dragged deep into the Earth. That water helps rocks melt, creating magma. The magma rises, erupts as volcanoes, and releases gases like carbon dioxide into the atmosphere. So when there were fewer subduction zones, there were fewer volcanoes, and less carbon dioxide was pumped into the air. It went like this. The supercontinent Nuna broke apart, and it created lots of brand new ocean floors in young seas that didn't exist before. These new ocean floors pulled carbon dioxide out of the air. Seawater flowed into cracks in the ocean floor. When that happened, carbon got trapped in rocks, forming limestone. Over time, this process locked carbon away inside Earth instead of letting it stay in the atmosphere. With less carbon dioxide, Earth slowly cooled down. That cooler climate helped the new shallow seas become stable and rich in oxygen. Such calm, oxygen-filled environments are perfect for life to become more complex. Those huge shallow seas near the continents acted like safe nurseries for early life. They may have helped eukaryotes evolve faster. Eukaryotes are living things with complex cells. Cells that have parts inside them, like a nucleus that holds DNA. Every animal, plant, and fungus on Earth comes from these kinds of cells. So when eukaryotes appeared, it was a huge moment in the history of life. Scientists already knew that eukaryotes showed up during the Boring Billion because of fossils that are about 1 billion years old, but they didn't really know why this happened at that time. Now, scientists want to find better preserved early eukaryote fossils to learn exactly how complex life first evolved. Life on Earth started over 3 billion years ago. It began with tiny, simple microbes and slowly turned into a huge variety of living things. We still don't have a clear answer about how living things came out of that early primordial soup, but even though there's no final answer yet, scientists have come up with several theories to try to explain how life on Earth may have started. Some scientists think lightning helped start life on Earth. The idea is pretty simple. Lightning is a powerful spark, and sparks can cause chemical reactions. In a famous experiment from 1952, scientists showed that electric sparks could turn simple gases like water vapor and methane into amino acids and sugars, which are basic building blocks of life. This suggested that lightning in early Earth storms might have helped create the first life ingredients. But later research showed Earth's early air wasn't exactly like the experiment. Still, some scientists think volcanic clouds could have had the right gases and lots of lightning, making this process possible. Other experts think life may have started on clay. One researcher suggested that tiny clay crystals could grow and stick together in patterns. As they did, they could trap simple molecules and line them up in organized ways. Think of clay as a kind of early organizer. Today, DNA tells molecules how to line up and work together. But what if clay had been doing a similar job before DNA even existed? It could be helping molecules arrange themselves until they eventually learned to organize on their own. This idea was interesting and got a lot of attention, but most scientists don't fully accept it yet. Another popular theory is that life started at deep-sea vents on the ocean floor. These vents are cracks in Earth's crust where super hot water shoots out from deep inside the planet. As the water rises, it picks up important chemicals like carbon and hydrogen, which are key ingredients for life. The vents are full of tiny rock spaces where these chemicals could collect, mix, and react. The rocks may have helped speed up these reactions. Even today, deep-sea vents house rich ecosystems, even though it's dark there and the whole environment is kinda extreme. Scientists are still studying this idea. In 2019, researchers even created early life-like structures in lab conditions similar to these vents. Such an experiment showed that this theory could really work. Another idea is that life may have started under ice. Scientists believe Earth's oceans might have been covered in ice around 3 billion years ago. Sounds pretty severe, right? But the cold may have actually helped life get started. Many of the chemical building blocks of life, like simple amino acids, are more stable at low temperatures. In warmer water, these molecules break down quickly and are spread far apart. But when water freezes, it pushes those molecules together, increasing their concentration. This crowding makes chemical reactions more likely. So, let's say the molecules were packed closer together and were breaking down more slowly. In this case, they had more chances to link up and form more complex structures. Ice may have also acted like a protective blanket. It could shield the water from harmful ultraviolet radiation from the sun and from damage caused by meteor impacts. Another idea is that life didn't start on Earth at all. This theory is called panspermia, and it suggests that life came from space. Scientists know that big asteroid impacts can blast rocks off of planets. For example, rocks from Mars have been knocked into space before, and some of them ended up on Earth. Some researchers think tiny microbes might have survived inside space rocks during the journey. If that's true, life here could have started thanks to visitors from Mars, or some other cosmic world. Others go even further and suggest that life could have traveled on comets or space dust from completely different star systems, hitching a ride across the galaxy. At the same time, even if panspermia is real, it doesn't fully solve the mystery. It just moves the question somewhere else. Instead of asking how life began on Earth, we'd need to ask, how did life begin anywhere in the universe? While you're watching this video, pieces of continents are slowly breaking off from below and are pulled down into the oceanic mantle, a hot, mostly solid layer that moves slowly under the seafloor. As soon as these fragments reach the mantle, they can trigger volcanic eruptions in parts of the ocean where there are no volcanoes. Plus, when continents break apart, it happens not only at the surface, but also deep down. But more on that later. This process can continue for tens of millions of years. The new study shows that Earth's insides are even more dynamic than we thought. It also explains why many volcanic islands, including Christmas Island in the Northeast Indian Ocean, contain unusually high levels of certain chemical elements. The thing is, these elements are normally only found in continental crust. Well, scientists did suspect that these elements showed up because some powerful forces deep inside the Earth took old, recycled pieces of rock and mixed them into the mantle. This process works a bit like when you mix together ingredients for cake batter. But before, researchers believed those elements came from two main sources: sediment that sank into the mantle as oceanic plates got pushed down, or from mantle plumes. Those are columns of hot rock rising up from deep inside Earth. However, these explanations don't fit all observations. In some volcanic areas, there's almost no sign that the crust has been recycled. In other places, the mantle seems to cool and too close to the surface to be affected by the rising hot rock. Scientists used to wonder how this could happen. Now we know that some of the material in those regions comes from pieces of continents that sink deep into the mantle, and these pieces affect the volcanoes that form above. The new study also suggests a curious idea. Continents don't just break apart at the surface, they peel away from below too. And this can happen over much greater distances than scientists thought before. Researchers used simulations to figure out how continents and the mantle behaved when stretched by tectonic forces. Their work is built on earlier research showing that when continents split, deep, powerful forces inside our planet create a mantle wave. This wave moves along the base of the continent at depths of about 90 to 125 miles. The wave moves extremely slowly, about a millionth of the speed of a snail, and gradually strips material from the roots of the continents. These peeled-off fragments are then carried sideways, sometimes more than 620 miles, into the oceanic mantle. Once there, they can trigger volcanic eruptions in the ocean for tens of millions of years. The research also shows that the mantle continues to feel effects of continental breakup long after the continents themselves have separated. Even after a new ocean basin forms, the mantle keeps moving, reorganizing and transporting enriched material far from where it originally came. To make this conclusion, researchers studied geochemical data from different parts of the Earth, including the Indian Ocean Seamount Province. That's a chain of volcanic formations that appeared after the supercontinent Gondwana had broken apart over 100 million years ago. Their computer models and chemical tests showed that right after the supercontinent Gondwana broke apart, a lot of magma with unusual chemicals pushed up to the surface. over millions of years, this chemical signature slowly faded as less material came up from under the continent. The most unexpected discovery is that this happened without any help from those deep, hot columns of rock scientists used to think were needed. Now, to get an even clearer picture, let's sneak a peek into our planet's insides. Earth is about 4.6 billion years old. It was born from a huge cloud of dust and gas that slowly cooled, shrank, and hardened into the planet we know today. As it cooled, heavy metals like iron and nickel sank to the center, and lighter, rocky materials floated upward. This created the Earth's layered structure, with each layer having its own unique properties. The crust is like Earth's skin. It's our planet's outermost layer made of solid rock. It's broken into huge pieces called tectonic plates that slowly drift over time. There are two kinds of crust: oceanic crust and continental crust. The oceanic crust is about 4 to 6 miles thick. It's covered with a thin layer of sediments like sand, clay, and shells. Below that are dense rocks like basalt, rich in magnesium. As for the continental crust, it's thicker than oceanic crust and is located under continents. It's made of lighter rocks than oceanic crust. Beneath the crust is the mantle. It makes up more than 75% of Earth's volume. The top of the mantle is pretty rigid, but deeper down it becomes soft and partially molten, which allows it to flow slowly. This flow is what moves the tectonic plates. At the center of the Earth lies the core. It's made mostly of iron and nickel and has two distinct layers, the outer core and the inner core. The outer core is a liquid layer of iron and nickel. It's insanely hot, up to 10,800 degrees Fahrenheit, as hot as the surface of the sun. The outer core also generates Earth's magnetic field, which protects us from harmful solar radiation. The inner core is solid because of the crushing pressure inside the planet. It's also made of iron and nickel. Now, the Earth's outer shell, called the lithosphere, is made up of the crust and the uppermost part of the mantle. It's broken into large pieces, called tectonic plates. There are a few super large plates and many smaller ones. 6 of the major plates are named after the continents they carry, like the North American, African, and Antarctic plates. But even those smaller plates play an important role. For example, the tiny Juan de Fuca plate is responsible for many of the volcanoes in the Pacific Northwest of the United States. The plates are moving like a jumble of old conveyor belts. They move very slowly, about 1 to 2 inches per year. But over millions of years, this movement shapes the face of our planet. Most earthquakes, volcanoes, and mountain building happen where plates meet, pull apart, or slide past each other. There are 3 main types of plate boundaries: convergent, when plates move toward each other; divergent, when plates move apart; and transform. That's when plates slide sideways past each other. When tectonic plates collide, the crust crumples and buckles, forming mountain ranges. About 55 million years ago, India crashed into Asia, slowly creating the Himalayas, the tallest mountains on Earth. The collision continues today, so the mountains are still rising. Mount Everest, the highest point on Earth, may even grow a tiny bit taller over time. At some convergent boundaries, an oceanic plate dives under a land plate in a process called subduction. The land above lifts up, forming mountains, and the sinking plate melts and triggers volcanic eruptions. This is how some mountains in the Andes of South America were formed. When 2 oceanic plates collide, one usually slides beneath the other, creating deep ocean trenches, like the Mariana Trench in the North Pacific, the deepest point on Earth. These collisions can also form underwater volcanoes that eventually rise above the ocean and turn into island chains, such as Japan. At divergent boundaries, tectonic plates move away from each other. In the oceans, magma from deep in the mantle rises to fill the gap. This creates underwater mountains and volcanoes along the seam. This process renews the ocean floor and slowly widens the ocean basins. By the way, a single mid-ocean ridge system connects all the world's oceans, making it the longest mountain range on Earth. On land, when plates pull apart, they form giant valleys, such as the Great Rift Valley in Africa. If this stretching continues over millions of years, East Africa could split off to become a new landmass. One famous example of transform boundaries is the San Andreas Fault in California. Unlike convergent or divergent boundaries, transform boundaries usually don't create mountains or oceans, but the grinding motion can cause powerful earthquakes, such as the 1906 earthquake that destroyed much of San Francisco.
If you wander about 1,800 miles from Madagascar into the middle of, well, basically nowhere, you'll reach the Kerguelen Islands. This remote French territory is one of the most isolated places on Earth. There's no airport, no native population, not even Wi-Fi, just brutal winds, freezing rain, and rough seas. But this place also hides a massive secret beneath the water, because what you perceive above sea level is only the tip of something far bigger, the peaks of an enormous landmass that mostly sank into the ocean. We're talking about the Kerguelen Plateau, a lost, sunken continent. This is a big, mostly submerged volcanic plateau in the southern Indian Ocean. It sits about 1,900 miles southwest of Australia and is nearly 3 times the size of Japan. But don't bother trying to spot it on a world map, because to really see it, you'd have to dive deep. And I mean that literally, since big chunks of it now lie more than 6,000 feet under the ocean. Now, it wasn't always like this, though. For long stretches of time, large parts of the Kerguelen Plateau were above sea level, forming a huge microcontinent. That was roughly between 100 million and 20 million years ago. Back then, scientists think this land was covered in dense forests, packed with trees like araucarias and cypresses. But it wasn't exactly peaceful. Active volcanoes were everywhere, with lava flows probably spilling across the land. And not to mention the dinosaurs. There's some evidence that lizards and dinosaurs once lived there, but they were likely the smaller ones, not the big scary kind. Another cool theory is that the Kerguelen Plateau once acted like a long land bridge connecting Antarctica and India. People believed that for a long time, but more recent research suggests it's probably not true. Even back then, there were still huge stretches of open water separating these landmasses. But anyway, today the trees are gone, and those ancient volcanoes are quiet, hidden underwater. So, you might be wondering, how did this whole chunk of continent sink and basically disappear? Well, we'll get to that in a second. But first, we need to answer a basic question. How did the Kerguelen Plateau form in the first place? Well, our story starts about 130 million years ago. Back then, Earth had Gondwana, a giant supercontinent that included what are now South America, Africa, India, Australia, and Antarctica. But eventually, it began to break apart. And during that long, dramatic breakup that happened over millions of years, the Kerguelen Plateau was born. And it basically exists thanks to something called the Kerguelen Hotspot. The Kerguelen Hotspot is a region deep inside Earth where super hot melted rock slowly rises toward the surface. You can think of it like a steady underground burner, melting rock in the same spot for a very, very long time. And even though the hotspot stays put, Earth's outer shell keeps moving above it. So as the seafloor drifted over the Kerguelen hotspot, huge amounts of melted rock spilled out, cooled down, and stacked up, layer after layer. Over about 30 million years, that process built a massive mound of volcanic rock on the ocean floor. At the peak of the eruptions, it may have added around 7 to 8 inches of lava every year. To put that into perspective, that's enough new lava to fill about 184,000 Olympic-sized swimming pools, if there were that many. And little by little, that volcanic pile kept growing, bigger and bigger, higher and higher, until it finally rose above sea level and became the Kerguelen Plateau. But then, something strange happened. Over the last 20 million years, this landmass started to sink, slowly but steadily. Today, most of it sits roughly 3,300 to 6,600 feet below sea level, and only a couple of spots have managed to stay above water. One of them is the Kerguelen Islands, that French territory we mentioned earlier, and the other is the McDonald Islands, which belong to Australia. Okay, but how did all the rest of it sink? Well, continents don't end up underwater because they suddenly drop like stones. Instead, this process happens because Earth's surface slowly bends, stretches, and shifts over very long periods of time. The outer shell of the planet is broken into huge pieces, the tectonic plates. These plates float on a hotter, softer layer of rock beneath them, known as the mantle. When a continent gets pulled apart by forces deep inside Earth, its crust stretches out, gets thinner, so it starts to sit lower. And as it drops, the ocean doesn't come rushing in all at once. Instead, seawater slowly spills over the edges, flooding the lowest areas first and turning dry land into shallow seas. Meanwhile, the rock underneath cools down, and when it cools, it contracts and sinks, which pulls the surface down even more. On top of that, sediments keep piling up, almost like heavy blankets, adding extra weight and pushing the crust lower and lower. And that's basically what happened to the Kerguelen Plateau. Parts of it once rose above sea level and even had forests, but the sheer weight of all that basalt, along with shifting tectonic plates, gradually pushed it back down into the deep ocean. In the end, only the highest volcanic peaks stayed above water, and those are the islands we see today. Now, here's a big question. If most of it is underwater, can we still call it a continent? Well, in a way, yeah. In fact, scientists have described it as a microcontinent since the 1970s. And that's because what really separates continents from ocean basins isn't whether they're above water, it's the type of crust underneath. Earth basically has two main kinds of crust, rising and deep dish. Wait a minute, that's pizza crust. Oops. The Earth's crust comes in either continental or oceanic. Continents are made of continental crust. It's thicker, lighter, and usually much older, so it tends to sit higher and form land. It's also more granite-like in composition, formed from magma that cools slowly deep underground before it hardens. Then there's oceanic crust. That's what the ocean floor is made of. It's thinner, heavier, and much younger, so it sits lower and stays underwater. And it's mostly made of basalt, formed when rock in the Earth's mantle melts and rises up. Now here's where the Kerguelen Plateau gets really interesting. Even though the whole region is basically underwater, it isn't just normal ocean floor. And even though it's built from huge amounts of basalt, it doesn't behave like typical oceanic crust. Since this basalt was piled up over millions of years, the crust there became much thicker than normal oceanic crust. It also contains fragments of continental crust from the breakup of Gondwana. So that's basically why we consider it a continent. But you're not going to see the Kerguelen Plateau listed as one of Earth's main continents, just like Europe or Africa. And honestly, that's mostly because it would be a headache. A lot of people don't realize this, but the way we label continents is based more on convention than on one strict scientific rule. Because if we started teaching that the Kerguelen Plateau counts as a continent, we'd have to take a serious look at a bunch of other places too, like Zealandia, this almost completely submerged chunk of continental crust in Oceania. And it doesn't stop there. There's Pangea, Doggerland, Mauritia, Sahul, and Sunda, all regions that were once dry land or made of continental crust, but are now partly underwater. So, imagine if we started calling all of them continents. Earth would go from having 7 continents to what, 10, 12, more? It would get confusing fast. That's why the Kerguelen Plateau is usually described as a microcontinent or a sunken continent, not like a full continent, and certainly never an incontinent. That doesn't make it any less interesting, though. These days, the area is still volcanically active. The eruption rate dropped a lot over time, and has stayed relatively low ever since. But the system is still going. And that's already pretty wild, because activity like this usually only lasts 1 to 5 million years. So, in a way, the Kerguelen Plateau behaves like one of Earth's longest-running supervolcano systems. And it's still not done. Now quick, how many continents are there on Earth? You'd probably say 7, I would. But honestly, this question doesn't have a right answer anymore. Technically, yes, Earth has 7 continents. But our geography books have been ignoring this whole part of the world. For years, scientists have been arguing that there's actually an 8th continent hiding out there, and it's called Zealandia. Turns out this lost continent isn't so lost anymore. A few years ago, researchers finally mapped out exactly where Zealandia is and how massive it really is. And that was a first, because Zealandia is nothing like the other continents. Think about it. Asia, Europe, Africa, you can spot them from space, or better yet, just look down at your feet. Right now, you are standing on a continent. But most people don't realize every continent on Earth has parts we can't step on, or even see. A lot of their land is hidden under the ocean, and those areas are tough to map or even explore. Now, imagine a continent that's 94% underwater. That'd be almost impossible to find, right? Well, that's Zealandia, a massive chunk of land located beneath the Pacific Ocean. And there's a reason for that. A long time ago, Zealandia was part of Gondwana, an ancient supercontinent that included South America, Africa, Antarctica, Australia, and parts of Asia. For millions of years, Gondwana held together until it started breaking apart about 200 million years ago. Its pieces slowly drifted in different directions, and one of them was Zealandia. At first, it was still connected to both Australia and Antarctica. But around 85 million years ago, Zealandia finally split off and began drifting on its own, becoming an isolated continent. Now, unlike Australia or Antarctica, Zealandia didn't stay on the surface for long. It sank. Today, only a small part of it sticks out above the ocean. That's mostly New Zealand, plus New Caledonia, and a few smaller Pacific islands. The rest is hidden under the sea. But hold on, how did Zealandia sink in the first place? For years, most experts thought Zealandia broke away in a process called a strike-slip breakup. That's when continents split apart along huge strike-slip fault zones, places where tectonic plates slide past each other side by side. But something about that theory never quite added up. After years of research, scientists think they have finally cracked the mystery. Turns out Zealandia's crust, or the outer shell of the continent, had been stretched thin. Yep, that's right. Instead of sliding sideways, like they once thought, the land was actually stretching and breaking. It's just like pulling a piece of dough until it gets so thin it finally tears. That's basically what happened to Zealandia. The land stretched so much it eventually snapped, and that happened because the tectonic plates beneath Zealandia were pulling apart, thinning the crust until it finally broke. And when it did, it cracked big time. The cracks were big enough for ocean water to rush in through the gaps, creating what we now know as the Tasman Sea. A few million years later, even more stretching left Zealandia's crust thinner and weaker. Eventually, it gave way, and huge parts of it sank beneath the waves, sealing its fate as a lost continent. But it wasn't all that lost. Experts had actually suspected its existence for almost 400 years, and the big clue was its unusual thickness. You see, Earth's crust comes in 2 main kinds. We've got continental crust and oceanic crust. They're both part of the planet's outer shell of solid rock, but there are some big differences between them. The continental crust is kind of like a Chicago deep dish pizza. It's thicker. The oceanic crust, on the other hand, is more like a New York slice, thinner. Now let's drop both slices into a tank of water and see what happens. Okay, let's just say the deep dish is lighter, so it floats. That's why continents sit above the ocean. The New York slice is heavier, so it sinks to the bottom of the tank. And that's why oceanic crust ends up lower, forming the ocean floor. There's another key difference too. Continental crust is made of lots of different types of rock, while oceanic crust is mostly basalt, that dark volcanic rock we get from eruptions. Knowing this, scientists used advanced technology to investigate the South Pacific. And what they found was surprising. Areas once thought to be ordinary ocean floor were actually basalt-free and much thicker than ocean crust should be. So wait, could our sunken New York-style pizza actually be a Chicago deep dish? Well, yeah. Even though Zealandia's crust is still thinner than other continents, it's way thicker than real oceanic crust, which means it's not just a patchwork of ocean floor and continental scraps. It's all continental crust, just a drowned version of it. In February 2017, scientists made the big announcement. Listen, everyone, Earth has 8 continents. Ta-da! But back then, they had no idea what Zealandia really looked like. There wasn't a map or anything, and that's probably why so many people still don't know it exists. Even inside the scientific community, not everyone was thrilled about calling it the 8th continent. Some people believe that the strange land at the bottom of the ocean was just a bunch of submerged fragments or microcontinents. Now here's the thing though. Even before that big public announcement, an international team had already set sail on an expedition. They went near New Caledonia to collect seabed rock samples from North Zealandia, more precisely from Fairway Ridge in the Coral Sea. Fast forward 6 years, and those very samples unlocked a major discovery about Zealandia: its true size. The combination of rock dating methods, magnetic signatures, and tectonic mapping helps scientists define where Zealandia's boundaries lie. And they found that Zealandia has nearly 2 million square miles of landmass. To put that in perspective, that's about 20 times bigger than New Zealand. For many specialists, its size and completeness basically rule out the idea that Zealandia isn't a real continent. But why doesn't it feel official yet? I mean, we don't see it on maps, right? Well, that's because it's hard to get everyone to agree on calling it a continent. And the biggest reason people resist it so much might be pretty simple. It's just not convenient. You see, continents are generally identified by convention rather than by strict criteria. Depending on the perspective, people recognize 4, 5, 6, or 7 continents, because there's no such thing as a continent authority, and you are not going to see an international commission go on TV to name a new continent, or to make an official list of how many there are. Being almost entirely underwater doesn't help Zealandia's case. I mean, is it really fair to call it a continent like Asia or Africa? Some people argue that if Zealandia qualifies, then other smaller blocks of continental crust, like the Cocos Islands or other microcontinents, could also make the list. So, how many more continents would we have to add to the list? See why it's not very convenient? Maybe it's safer to call Zealandia a submerged or sunken continent. That's more accurate. Although, to be fair, the true definition of a sunken continent is still kind of fuzzy. But honestly, I wouldn't worry too much about the official definition of Zealandia. What really matters is that fully mapping it is already a big deal. Just keep in mind that large parts of it remain unexplored. Scientists are confident that technologies like seismic imaging and deep-sea drilling will uncover even more about its structure and history. And just because Zealandia is mostly underwater doesn't make it any less of a geological marvel. This sunken landmass actually preserves clues about Earth's past that we might never see on continents above the surface. It might help scientists understand how continents shift as the plates move around. They also hope to find more clues about how drifting continents affect sea level, climate patterns, and the distribution of plants and animals. Each new discovery could sharpen our understanding of how Earth's surface reshapes itself. So, continent or not, Zealandia has already changed how we see our planet. New Zealand is located in the southwest Pacific, and it isn't just a country of mountains, the world's quirkiest creatures, and hobbit holes. But here's another cool fact. New Zealand sits on top of a hidden continent that's 94% underwater. That's right, just the tip of a sunken landmass more than half the size of Australia. And with sea levels rising, one question keeps, well, surfacing. Is it possible that all these remarkable creatures will need swimming lessons one day? Zealandia is a sprawling, drowned continent stretching from New Zealand to New Caledonia. This underwater region has mountains, valleys, and its own geological personality. But wait, how can something underwater be called a continent? Well, it turns out being underwater doesn't disqualify you from being a continent. It just makes you harder to spot. Most people think of continents as giant land masses you can walk on. But geologists don't define continents by what's above water. They define them by what they're made of. You see, most of Earth's crust is oceanic, thin, dense, and made of basalt. However, continents sit on continental crust, which is thicker, lighter, and much older. That's the case with Zealandia. Even though it's mostly submerged, it's composed of the same kind of crust as Australia or South America. It has mountain ranges, sediment basins, fault lines, it's not your fault, and even fossils that prove it once had forests and land creatures. Zealandia was above sea level during the age of dinosaurs, and while we haven't found a raptor-like theropod skeleton yet, there's no reason to believe we won't. So how was this discovery made? Since most of Zealandia sits about 1/2 to 1.5 miles underwater, it wasn't easy. We can't drain the region like a bathtub just to take a look. So the answer had to be technology. Scientists used satellites to calculate tiny changes in Earth's gravity to spot what was hiding under the waves. Yep, fun fact, there are satellites that can measure gravity now. For example, NASA's mission GRACE has 2 satellites that find small changes in Earth's gravity. It does this by measuring how far apart the satellites are as they move over different things. Scientists also use sonar to map out the underwater mountains and valleys in 3D. Finally, deep ocean drilling pulled up ancient rock, soil, and even land-based fossils from beneath the seafloor. Physical proof that this wasn't just the ocean floor. Not that scientists use all this tech in that exact order, like following steps on a checklist. It actually took decades of overlapping data from land, sea, and space to connect the dots. By the early 2000s, enough evidence had piled up that some geologists began to speak openly about a possible hidden continent. Still, it wasn't until 2017 that Zealandia was formally proposed as one, backed by clear geological criteria. And in 2023, after decades of mapping and research, Zealandia became the first continent to be fully mapped while almost entirely underwater. But why did it sink in the first place? Long ago, all of Earth's land was joined in a single supercontinent called Pangea. Around 200 million years ago, yeah, I wasn't around then, it began to split apart. The northern half became Laurasia, which included what is now North America, Europe, and most of Asia. The southern half became Gondwana, made up of present-day South America, Africa, Antarctica, Australia, India, and Zealandia. About 85 million years ago, Zealandia broke off from Gondwana. It used to be connected to Australia and Antarctica, but when it split, its crust became too thin and stretched out. That made it less sturdy and more prone to sinking. You can think of it like a piece of ice that floats lower in the water after it breaks off a bigger chunk. Over time, tectonic forces, like plate movement and the loss of its deeper support, caused most of it to sink. It didn't just sink because it was weak, but because it was pulled down by Earth's shifting plates. It settled lower into the mantle because it didn't have the structure to stay higher up. Today, only the highest ridges, like New Zealand, remain above water. That's kind of cool to think about. If Zealandia had never sunk, Wellington would be somewhere up to 9,800 feet high. That's higher than Aspen, Colorado. Now, we know New Zealand is packed with weird and wonderful animals, birds that can't fly, bugs that glow, sheep that outnumber people. But what about its underwater world? Is it just as special? Actually, yeah. And honestly, maybe even cooler. Zealandia's sunken edges are home to marine life that's just as unique and isolated as the wildlife on land. We're talking thousands of species that evolved in near total obscurity, tucked away on a submerged continental shelf. Think of it as Earth's secret underwater lab. This is all thanks to diverse temperatures and over 50 different habitats in coastal regions alone. Take fish, for example. Some are delicious. But around 300 species found in these waters are endemic, meaning if you don't live near New Zealand, you'll never see them. This cute little fish is called southern lemon sole, and it stands out with its asymmetrical, pancake-like body and the odd habit of burying itself almost completely in sand, leaving just its eyes poking out. And the deeper you go, the stranger it gets. Zealandia's underwater slopes and canyons have creatures that feel like they were designed during a power outage at the evolution lab. My favorite is carnivorous sponges. Yep, sponges that eat meat. There are also sea daisies, which are small, flat, round creatures that don't seem to fit neatly into any specific family of animals. Scientists have discovered these unique little animals hanging onto sunken wood more than half a mile deep in the ocean. They're so unusual that researchers almost created a separate category just for them in the echinoderm family tree, which includes other marine life like starfish and sea urchins. And then there's the New Zealand scamping, a lobster-like crustacean that lives in muddy burrows on the ocean floor. This creature snacks on jelly-like blobs, ghost sharks, and pretty much anything that floats by. Even seaweeds are unique there, although they're not as cool as predatory sponges. Oh, by the way, an interesting fact about the regions close to New Zealand is that they hide active underwater volcanoes. The most famous one is called Brothers Seamount. It's located about 210 miles northeast of New Zealand. It's a massive underwater volcano with a crater at the top, constantly bubbling with heat and chemicals. What makes it fascinating is that these vents, called black smokers, support ecosystems that don't rely on sunlight. Instead, bacteria use chemicals like sulfur to produce energy, a process called chemosynthesis. These bacteria form the base of a food chain that includes species like tube worms and deep-sea shrimp, which are adapted to survive in extreme heat, pressure, and complete darkness. That's not typical for most ocean life, which depends on photosynthesis and stable conditions. Brothers Seamount is also loaded with metals like copper and zinc, making it scientifically valuable and, potentially, commercially tempting. So it goes without saying that Zealandia is incredibly important to scientists. It offers a unique window into Earth's geological and biological history. It's like a time machine and a natural lab that helps scientists piece together Earth's history. So, in the end, could New Zealand end up underwater due to water levels rising naturally with each century? If you're imagining New Zealand slowly disappearing beneath the waves, like a real-life Atlantis myth, don't. Even with sea levels rising, that kind of full-on submersion just isn't likely, even in the worst-case scenario. New Zealand's tallest point, Mount Aoraki, stands over 12,000 feet above sea level. For the ocean to cover that, it would need to rise by more than 2 miles. And unless Earth suddenly turns into a water balloon, that's not happening. Okay, but what about sinking? Could it sink like Zealandia did? Zealandia sank because it had a thin, stretched-out crust. It didn't have the strength to stay up. But New Zealand? It's sitting on the sturdy, lifted backbone of the continent. In fact, thanks to tectonic plate collisions, parts of it are actually rising every year. And not just rising, shaking too. Zealandia has active tectonic plate boundaries, which is why the region gets so many earthquakes and volcanic events. So, while Zealandia may be almost entirely underwater, New Zealand is holding its ground, literally. In other words, the Kiwi won't need swimming lessons anytime soon. Wow, this port is so buzzing. Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, You're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool. Your couch is standing on the floor, your floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere. It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of two plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these two plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruptions slowly push the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the Sixth Ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that Sixth Ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid, and before the Red Sea actually starts flowing in there, many thousands, if not millions of years must pass. The continents move as fast as your nails grow, and imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the Afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts, and there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within, and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the Afar Triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to Southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow, just about 1.2 inches a month. Some of them move even 5 times faster though, but even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes, neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangea supercontinent. Even though it formed over 300 million years ago and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangea. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole. Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in 2 main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's eighth continent. However, Zealandia is still debated because it's too big to be a microcontinent and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the fourth largest island in the world completely surrounded by water, but it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island at 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled and Greenland's motion away from Canada slowed dramatically when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent, and it didn't get pulled down into the earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion helps explain why some chunks of land break away cleanly, while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents, just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future. Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangea, or Pangea if you're feeling fancy. The name comes from a Greek word which means all the earth. Pangea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things changed. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learned their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean's surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
The floor is lava. Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
If you look at Earth from space, you'll see a blue planet. Almost 70% of its surface is covered with water. But if you gathered all the water into a sphere, it would be just barely big enough to cover Texas. Wow, what a big water balloon that would make. Scientists are almost certain that our planet once had 2 moons. At some point, long ago, one of them crashed into the other moon, which is now Earth's only natural satellite. Until recently, there was one more object orbiting our planet. It was a temporary mini-moon called 2020 CD3. This tiny space rock was pulled into our orbit more than a year ago. Astronomers believe the mini-moon left Earth's orbit in March. See ya! In July, when we're further from the Sun, the world is warmer overall than in January when we're closer to it. This is because, with Earth's tilt of its axis, there's more dry land in the northern half of the planet than the southern half, and land tends to heat up more than water. During the northern summer in July, more land is heated up than January, so the planet gets a little warmer at this time, even though we're further from our source of heat. What's on the menu? Astronauts tasted the first food grown and harvested in space in 2015. It was red romaine lettuce that had been growing in a special chamber for 15 months. Salad days in space. Mount Everest might be getting all of the attention, but Mauna Kea in Hawaii is technically the tallest mountain in the world. Measuring from base to summit, the only thing holding Mauna Kea back from the title is that it's mostly underwater. The Earth has 3 main layers, 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle, and then follows the thin crust, the surface that supports life as we know it. At least that's what we thought, because now scientists have found a new, mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. Now, any place that gets very little water each year is considered a desert. And because Antarctica is roughly as big as the US and Mexico combined, it actually wins the title of the largest desert in the world. Now, one scientist has a theory that a substance existed in ancient microbes before chlorophyll evolved on Earth. That's the stuff that makes plants green. This earlier substance reflected sunlight as red and violet colors, which combined to make purple. Now, if true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The rocks, metals, and other minerals and things that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. How high up you are also has an effect. So, if you were at the top of Mount Everest, you'd also weigh slightly less. Hey, don't look down. The Hudson Bay of Canada is a gravitational anomaly. This area has lower gravity than any other place on Earth. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed-up heads. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. Ooh, that is tough. They handled all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. Now, there's no solid land under the North Pole. All you can see there is sea ice. Oh, by the way, the gravitational pull is stronger at the poles, and if you travel there, you'll weigh a bit more, besides all the heavy warm clothes you're wearing. 99% of gold ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. That's enough to coat the entire planet's surface of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even more rare. If two pieces of the same kind of metal touch in space, they bond and get stuck together. It doesn't happen on Earth because water and air keeps pieces apart. Now it turns out we live inside the Sun. Well, sort of. Its atmosphere stretches far beyond its visible surface, and even though Earth is far away from the star, it's still within the reach of the Sun's atmosphere. Auroras happen when charged particles from the Sun get caught by Earth's magnetic field and crash into the upper atmosphere near the poles. Earth's southernmost continent, Antarctica, is only the fifth largest one, but it contains almost 70% of the planet's fresh water and 90% of the world's ice. Our planet has its magnetic field thanks to scorching hot liquid metal that's flowing inside its outer core. This creates electric currents, and they, in turn, generate the magnetic field. Earth is the densest planet in the solar system, but this density varies depending on where you're looking. For example, the crust is less dense than the solid metallic core. You're walking, running, jumping, but when you stop, it always feels like you're standing still. Well, in reality, you're moving even when you're perfectly still, because Earth is always on the move. Not only does it spin on its axis at 733 miles per hour, depending on where exactly you're standing, but it is also orbiting the Sun at a speed of 66,600 miles per hour, completing the trip in 365 days or so. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. The depths of our planet are filled with magma. As magma is going out on the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all the other processes bring that rock to the Earth's surface. There, erosion shapes it and shaves little bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. The first are the south and north magnetic poles. They affect things like drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. The Earth absorbs heat from the Sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than the other, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. If you could take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds. And every 200,000 to 300,000 years, our planet goes through a magnetic pole reversal. It's not an instant process, though. It can last hundreds or even thousands of years. Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot. with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So, let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widen into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands, or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago. Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lunch, lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo Pangea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Mauritia gives an idea similar to Novo Pangea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American Plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing, because it sits on the African Plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American Plate, it also pushes the African Plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, But there's more. Africa is also being influenced by the East African Rift. It's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American Plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking. And the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a tabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive. Let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Uturuncu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years, by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Uturuncu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Uturuncu probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campi Flegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is, there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it. Around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. But more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington State in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. But experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. It will change the way the volcano might erupt. Popocatépetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatépetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too